Okay, moving now to section 6.1, part 1 video, section 6.1. And in this video, we're going to be talking about rational expressions. And we're going to be doing something with these rational expressions. But before I do that, let me first of all give you the definition of a rational expression. So take this definition down. This is the definition of a rational expression. Here's the definition, and it's real short. One polynomial divided by another polynomial. Okay, so a rational expression is just simply a polynomial over another polynomial. So just to give you a few visuals, you don't have to write these down. What you see right here in the middle of the page, from here all the way across to here. This is a rational expression. It's one polynomial over another. One polynomial over another. One polynomial over another. That's what a rational expression is. Now, what we're going to be talking about as part of this section is how do we simplify? Or another word is reduce a rational expression. How do we simplify or reduce a rational expression? Well, before I do that, let me just show you this. Suppose I wanted to reduce 6 over 8. Or to simplify 6 over 8. Now, there's a difference in the word simplify and in the word divide in mathematics. Anytime you hear the word divide, that means that the author literally wants you to take what's in the bottom and divide it into the top. Like when we do synthetic division, I didn't say simplify that, I said divide it. So you literally divide the bottom into the top. That's what divide means. So if I ask you to divide this, you'd have to take your calculator to divide this, because it doesn't divide evenly. 8 doesn't divide into 6 evenly. So if you divide this, your answer would be 0.75. You don't believe that? Take your calculator and take 6 divided by 8. So I'm not talking about dividing this. If I ask you to reduce this, what do you do when you reduce? You find a factor that divides into both of these. Now, we can do this in our head. What factor divides into 6 and into 8? Well, 2 will. So we divide 2 into 6 and 2 into 8. Now, when you were taught at a young age, you would do something like this. You'd take 6 over 8 and you'd say 2 times 3 and 2 times 4, and you cancel the 2's. And what's left is 3 over 4. But you do that now automatically in your head. So basically, when you simplify something, what do? You cancel common factors. Now, have we talked about factoring lately? Heavens, yes. I mean, 5, 5, 5, 6, 5, 7, every bit of that was nothing but factoring polynomials. So, what we're about to do is, don't write this down yet. We're going to be asked to reduce, or another word is simplify, this. Not divide it. Simplify this rational expression. Now, how do you simplify this rational expression? You do it the same way you do that 6 over 8. What you ask yourself is there a factor that's common up here that's also common down here? Now, how do you know if there is a factor that is common up here and down here? We're going to have to factor this up here and factor this down here. And if any of those factors look the same, we will cancel those factors. Now, what if it doesn't factor? Then we can't cancel it. So it has to factor in order for us to cancel it. So, let me give you a note. Title this note, write this down. Steps in simplifying rational expressions. So take this note down. Steps in simplifying rational expressions. There's 2 steps. Here are the steps. Step 1. Completely factor, and there are those 2 words again. We have talked about that a ton since we covered factoring. So back to step 1. Completely factor the numerator and denominator. Then step 2. Cancel common factors or negative factors in the numerator and denominator. And again, you can, rewind that until you make sure you have that definition down. Okay, let's start out with one first that we don't have to factor. So let's look at this first example. And the instructions here is simplify. Eight x to the 5th over 10x to the 3rd. Okay, normally what we would do is factor the top and factor the bottom. But we don't factor terms that have only one term in it. Remember, we only factor binomials, trinomials, and 4 terms. So, what I'll do is you can reduce this since this is one term over one term. What goes into 8 and 10? 2 will. 2 goes into 8, 4. 2 goes into 10, 5. And then this x3 cancels with this x5 and leaves x2. And you say, well, Ms. Reiner, we've already covered that earlier. And you'd be right. We have. Okay? Now, let's do another one that's more like what I want to show you in this section. So let's look at this one. 5x minus 15 over x squared minus 9. Now, let me say again here. Whenever you're simplifying, you don't start trying to mark this out and canceling. The first thing you do in every one of these problems is factor the top and factor the bottom. If you can't factor it, you can't cancel. Because what do you cancel? You cancel common factors. So I've got to be able to factor this before I can cancel. All right, so let's just ignore the bottom. How do you factor 5x minus 15? Well, it has a GCF of 5 times. You divide 5 into 5x, you're left with x. 5 into 15 is 3. Over. Now, ignore the top. Look at the bottom. X squared minus 9. Binomial, no GCF. This is the difference of 2 perfect squares. X plus 3 times x minus 3. So the top part has 2 factors. The bottom part has 2 factors. Now cancel your common factors. You can cancel it after you factor it. And when you do, it leaves understood ones. So that this reduces to that right there. Okay? Let's do another one. Let's do 8x squared minus 10x to the 5th over 4x. Okay, let me say again. In your head, don't start trying to mark out stuff. Factor the top, factor the bottom, and then cancel what you can. Well, the top part is a binomial. What's the first thing we look for? GCF. There is one, 2x squared. 2 goes into both of these, and you got an x2 and an x5, so x2 goes into both. Now divide. 2x2 into 8x2 would be 4, minus 2x squared into 10 would be 5, and x squared into x to the 5th is x to the 3rd, subtracting exponents. So there's two factors here, this and this one, over 4x. Now you can't cancel and go in here and cancel part of that binomial. You either have to cancel all of it or none of it. But what I can do is this 2 cancels with this 4, leaves 2, and this x cancels with that x squared and leaves x on the top. So the final answer is x times 4 minus 5x to the 3rd all over 2. And no, it does not serve any purpose to multiply that out. We're just factoring it so that we can cancel the common factors. Okay? Let's do another one. (28 minus 7x over x squared minus 16). All right, let me say once again, avoid the temptation of marking some of this stuff out. You do not cancel until you factor. If you cancel before you factor, the whole problem's wrong. Because you cancel factors. That's why it has to be factored first. Okay, so if I factor the top, the GCF is a 7. If I take out a 7, I'm left with 4 minus x. Now, the bottom is the difference of two perfect squares. X plus 4 times x minus 4. Now, this is the first time you've heard this before. If you say, well, 4 minus x and x minus 4, they're not the same, you are correct. And the reason is subtraction is not commutative. These two factors are what we call negatives of each other. For instance, 7 and negative 7 are the same numbers, but they're opposite signs. 10 and negative 10 are negatives of each other because they're opposite signs. The reason we call these negatives of each other is this. The 4 here is what? Positive. The 4 here is what? Negative. But the x here is negative and the x here is positive. If you have two binomials that are the same but their signs are just switched, those are called negative factors. Now, can you cancel negative factors? Yes. Can you cancel 7 into negative 7? Yes. When you do, it leaves negative 1. If you divide 3 into negative 3, it's negative 1. So when you divide this into this, it leaves a negative 1. Now, you don't put the negative 1 on the top and bottom, because if you do, a negative over a negative is a positive, and you've defeated the whole purpose in putting the negative there. Now, when you do this, this is not 7 minus 1. It is 7 times negative 1, which is negative 7 over x plus 4. So when you cancel factors, you can cancel like factors and negative factors. Okay? Let's do another one here. X squared minus 2x minus 15 over x minus 5. All right, let me say again, avoid the temptation of start whacking out things here. Factor and factor. So if I factor the top, x squared is x and x. Signs are different. Largest is negative. Two numbers multiply 15, subtract 2. It's 5 and 3, but the 5 needs to be negative and the 3 needs to be positive. Over x minus 5. Then the x minus 5's cancel, leave 1s. So this is x minus 3. Now, if that x minus 3 had been in the bottom, sorry, x plus 3. If that x plus 3 had been in the bottom, you'd have to write your answer 1 over x plus 3. Okay, let's do another one. This one's real simple, but it just brings back the point that I wanted to say. X minus 3 over 3 minus x. Well, there's nothing to factor here because those won't factor. However, what did we say about x minus 3 and 3 minus x? They are negative factors of each other. So when you cancel, it just leaves negative 1. Okay, let's look at one more. Okay, the top part. Trinomial. There's no GCF. This is not the easy case because of the 2. Now, let me show you how this factors. That's how that factors. Now, you say, Mr. Wright, I don't see where that comes from. You take this and do the Brew method on it. If you go to the side and do the Brew method, that's what you'll get. So, if you need to go to the side, and you probably do, go to the side and do that. Now, the bottom is the difference of 2 perfect squares. So this is 5 plus x times 5 minus x. Now, x minus 5 and 5 minus x are negative factors of each other. So that leaves negative 1. And so I've got 2x plus 3 over 5 plus x. Now, we typically don't multiply that negative 3 there. What we usually do is just put the negative in front of the fraction bar. If you do that, that's the same. Now, if you want to distribute it, you can. And say negative 2x minus 3. That would be okay also. But typically, the way it's done is just put negative in front of the fraction bar to express that answer. Okay, so there's that problem. I just had a low battery pop up on my phone, so I'm not sure you watched all of that. So you factor this by the Brew method. This is difference of 2 perfect squares, and these cancel because they're negative factors, and we typically just put the negative out in front. Okay, I'm going to stop here. This is not the end of 6.1, but we will have one more video to close out section 6.1.